As we said earlier, the typical example I'm going to use for a production function is using water and fertilizer to produce corn. And the description of the production and the abbreviations were given in a previous lesson. I'm quite aware that the usual thing for textbooks to do is something quite different. Q equals F of K and L, where K is capital and L is labor. However, especially the notion of capital is problematic. Even the notion of labor here is quite abstract because there are obviously different kinds of labor. And Q here as some kind of generic output is also a very abstract notion. This would not be a good example to start with because there's nothing abstract about the main idea of a production function. The main idea of a production function is a simple recipe that describes the engineering and scientific possibilities of production. So water here is something concrete, fertilizer is something concrete, Q is something concrete. There's nothing abstract about it. And abstraction in this context can be problematic. I'll discuss one aspect that makes it problematic in a different lesson, but for the most part, we're going to be using this simple, easy to understand, concrete example of what production is. As always in this class, I'd like to draw a graph. And the easiest assumption to make is that increases in water, other things being equal, lead to increases in corn, and increases in fertilizer also lead to increases in corn. Clearly, this is not always true. If you put too much water on a corn crop, you can flood it. If you put too much fertilizer on a corn crop, you'll burn the crop. But for modest amounts of water and fertilizer, this is true. Using Q equals F of W and F makes this essentially a three-dimensional object with water on one axis, fertilizer on another, and corn on the third. And we've got some kind of three-dimensional figure here, which I'm not going to attempt to draw. Instead, we're going to use the technique we used before with contour lines. Now, it doesn't matter whether you put W on the horizontal axis and F on the vertical axis, or whether you switch them and put F on the horizontal and W on the vertical. Let's see what the contour lines look like. These would be the contour lines of the production function. We'll pick an arbitrary point. Let's say that's the, 10 bushel isoquant. Remember, bushels is what we measure corn in, and corn is the output. Now suppose we go in an arbitrary direction, let's say increasing fertilizer up to here. Well, increasing fertilizer will increase corn output, and that's what we said here. So this is more than 10 bushels. I'm trying to sketch the contour line. So I need to find another point here that has 10 bushels. And right now what I've achieved is something that's more than 10 bushels. In order to get to 10 bushels, I have to decrease water. Because increasing water increases output, but I want to decrease output in order to get back to 10 bushels so I can draw my contour line. And so if I want to decrease output, I need to decrease water. So decrease water to some amount, I don't know what the length would be, but some amount until you get back to 10 bushels, and then you can join these with a contour line because they both represent 10 bushels of output. So contour lines of the production function would be downward sloping. We have a special name for contour lines of the production function. They're called isoquants. Iso means equal, quant means quantity, so it's equal quantity of output. Other isoquants might be here and here. The ones closer to the origin will represent less output. And one way you can show that is that one way method of getting from the 10 bushel contour line to the other one that I drew is to get less fertilizer and less water. And certainly if you've gotten both less fertilizer and less water, you got less output. So this might be, I don't know, the 8 bushel isoquant. Similarly, this might be the 12 bushel isoquant. So in general, you have a whole series of isoquants filling up the WF plane, showing the possibilities for output. In the next lesson, we'll talk a little bit more about the shape of the isoquants.